3, pre-calculus. We're going over polynomial functions of higher degree. You've done linear and quadratic in Algebra 2. We're going to work on cubic and higher now. This first question, so what I'm going to do through here is I'm going to point out keywords and the directions and give you hints. If you're doing these online, then you can use the hints to help you answer your problems. If you're doing these on paper, then you're going to finish the problem on paper, probably another sheet of paper, and then turn them back in through the mail. So number 1, we're going to describe how to transform the graph, how we're going to move it around. For this polynomial that we start with, we have something with x to the n power. Compute the location of the y-intercept as a check of the transformation. So we're going to start looking at our function over here. We have g of x. Now we have x raised to some power. So our n value, they even told us down here, we're talking about a cubic function. So I want to go, is this moving right, left, up, or down, and is it stretched? So remember, inside with the x, that's the right or left direction. And remember, x's are special, is my way to say it. You want to be a little bit careful when you pick your direction. And then this number out in front, this 2 out in front, that's going to be your vertical stretch. Be really careful as you're entering these in. If you're doing this online, be real careful how you're entering them in to the function. Now the y-intercept, if we go to do the y-intercept, a new color here, the function f of x equals x cubed is going to be something kind of like this. And then when we move, this moves right or left, and then it stretches. The y-intercept, if x is 0, 2 times, you're going to play with that number. You can enter this in Desmos and look at your new y-intercept. So this is your, before I mess things up, the x cubed. So experiment and watch this question right here carefully, and then make sure that if you're working online, you're entering this as an ordered pair. So you're going to be typing in parentheses, comma, parentheses with numbers inside there. And what do they want you to do next? And then you're going to click these down below in this section here. Check or click on the ones that apply to this problem. They don't all apply, so be careful. Number 2, we're going to graph a polynomial and locate its extrema and zeros. Extrema are the max and the min, maximum or minimum, or the high point, or the low point. The zeros are the places where the graph crosses the x-axis. So you've got some x-coordinate that you get to find, and you know that the y-coordinate is going to be 0 on those. So if we start looking at our choices for our functions, now you could type this in Desmos and find the one that matches, but even better, you could use what you know about your formulas now, and you can start to say, okay, well, this leading coefficient is negative. This exponent is 4, so this is our flattened out parabola. Oh, except since this is negative, we're going to have a flattened out or some kind of funny shaped upside down quartic function. So I know right there that because mine needs to be upside down like this because of this negative leading coefficient, I immediately know that it's not A or B. So you're down to choices C and D, and then you're going to start looking at x-intercepts to figure out which one you're going to use for C or D. So C or D is our question. We're going to take our function, we're going to find the x-intercepts. So we're going to find the zeros. Notice C and D have different zeros, so that's going to help us figure out which one it is. So we're going to do that by factoring. So you're going to start, I'll just tell you to start by factoring out a negative x, and then you can finish that up. All right, number 3. Oh, one more note about this number 2. This local maximum, that's the value of the function, which means you're going to use the y coordinate right here. The local minimum, okay, is also a y coordinate. So we want to make sure we're using, y coordinates when we enter these numbers in on Desmos. The zeros of the function, we're going to enter the x coordinate and make sure that you're reading this so that you enter things in the form that they want. All right. Number 3, we're going to graph the function in a viewing window, so we're going to use this one. We're going to use Desmos. And we want to make sure that we show all of its intercepts. So you're going to just start by typing. And then you're going to change the size of the window. You can check down here, see how all your choices, your y's go from negative 33 to 18, and your x's are in all 4 of your choices are going from a negative 8 to 5. So what I would do is in Desmos, you're going to set your window in Desmos to match your choices. And from there, you should be able to spot the one that you need. In behavior notation, I think I'll finish explaining this and then I'll make another video for the next part. In behavior notation, using limits, this is new. It looks scary, but you guys, it's really not. When we write the limit, that's the way we say it, is the limit of some function, and we're going to write f of x so we don't have to type the whole function. Now here's the thing, mathematicians don't like anything extra, so we try to make things make sense. If I write x with this arrow in infinity, that's x approaches infinity, is the way we say it. What you're doing is you're looking at the far right side of the graph. So this x is, we're looking at x coordinates. And then when we go, I'm going to switch colors to try to make this make sense. When we see this number on the end, if I go equals negative infinity, infinity, that was weird. That number right there is the y coordinate. So x approaches, the arrow, the x is pointing at a number, that's the x coordinate you're looking at. Your answer in this limit notation is just your y coordinate. So I'm going to look at my graph. If I go way over far on the right side for this first notation, I'm going to look and see, is my graph having a y-coordinate of negative infinity. If not, this is not going to be my answer choice. So read the notation carefully. That's the new part for you. Takes a little bit of practice, but I have no doubt you can figure this out. Okay, that's new notation. So you're going to have to concentrate a little bit at first. All right, I'm going to stop this video. We'll